If you glanced at Mercury for just a second, you'd probably mistake it for our moon. It's dark grey, heavily scarred by ancient impact craters and utterly barren. But this isn't a moon. It's the smallest major planet in our solar system, sitting directly in the blazing crosshairs of the Sun. In fact, Mercury is barely larger than Earth's own moon. With a diameter of just under 3,030 miles, or about 4,880 kilometers, Mercury is actually smaller than some moons in our solar system, such as Jupiter's Ganymede and Saturn's Titan. Despite its calm, silent appearance, Mercury is the speed demon of the solar system. Because it orbits so close to the Sun, at an average distance of roughly 36 million miles or 58 million kilometers, solar gravity whips the planet along at a staggering 29 miles per second, which is equal to 47 kilometers per second. That is fast enough to cross the entire United States in under 2 minutes, or travel around the entire Earth in just 9 minutes. Because of this blazing speed, ancient astronomers named it after the fleet-footed Roman messenger god. Because of its relentless pace around the Sun, a single year on Mercury flies by in just 88 Earth days. But while its years race past, its days do the exact opposite. Mercury rotates on its axis at an agonizingly slow crawl. In fact, it takes 59 Earth days for Mercury to complete just one physical spin. Here is where time gets truly bizarre. Because of the way Mercury's slow spin combines with its egg-shaped elliptical orbit, a single solar day, the time from one sunrise to the exact next sunrise, takes 176 Earth days. That means on Mercury, a single day lasts twice as long as its entire year. If you stood on certain parts of its surface, you would actually watch the Sun rise, stop, reverse direction in the sky, and then set again, all before resuming its normal path across the sky. Living so close to a star creates extreme conditions like nowhere else in our solar system. On the side facing the Sun, temperatures climb to a scorching 800 degrees Fahrenheit. That's over 420 degrees Celsius. That is hot enough to melt solid lead, turn an industrial oven into an icebox by comparison, and cook an egg instantly upon impact. You might assume that all this trapped heat keeps the night side warm too, like Earth's blanket of air does for us. But Mercury has virtually no atmosphere at all. Instead, it has a paper-thin layer called an exosphere, made of loose atoms knocked off its surface by the solar wind and tiny meteorites, mostly oxygen, sodium, hydrogen and potassium. Without a real atmosphere to hold on to heat, the moment the Sun sets, temperatures plummet off a precipitous cliff. On the night side of Mercury, it freezes down to a bone-chilling minus 290 degrees Fahrenheit or minus 180 degrees Celsius. It holds the absolute record for the most violent temperature swing of any planet in the solar system, dropping by nearly 1,100 degrees Fahrenheit or over 600 degrees Celsius between daytime and nightfall. Yet, despite surface temperatures that can melt metal, Mercury harbours one of the biggest paradoxes in space: water ice. Near the planet's north and south poles, massive asteroid impacts left behind deep craters. Because Mercury stands almost perfectly upright without an axial tilt, tilted by less than 2 degrees compared to Earth's 23.5 degrees, the bottoms of these deep polar craters never see sunlight. They have been frozen in pitch-black shadow for billions of years. Spacecraft instruments have confirmed that inside these eternal shadows lie thick sheets of real water ice, several feet or over a meter thick, preserved in the solar system's ultimate freezer. Mercury's surface tells a violent story of ancient cosmic collisions. The largest feature on the entire planet is a giant impact basin named Caloris Basin. Measuring roughly 950 miles across, or 1,550 kilometers, this immense crater is wide enough to stretch from Texas to Canada. The asteroid impact that created Caloris Basin roughly 3.8 billion years ago was so cataclysmic that the shock waves travelled entirely through the planet, focusing on the exact opposite side of Mercury. There, the ground was violently shattered and churned up, creating a vast area of weird, jumbled terrain made of chaotic hills, ridges, and fractured cliffs. If we could slice Mercury in half like an apple, its interior would surprise you even more. Most rocky planets like Earth or Mars have a thin outer crust, a thick rocky mantle, and a modest metallic core at the centre. Mercury flips this rulebook completely upside down. Mercury's core is enormous. It has a radius of about 1,240 miles or 2,000 kilometers, taking up a staggering 85% of the planet's entire radius. Basically, Mercury is a giant ball of solid and liquid iron-nickel metal wrapped in a paper-thin shell of rock only 250 miles or 400 kilometers thick. Scientists believe that long ago, a massive planet-sized object collided with young Mercury, stripping away most of its original rocky outer crust and mantle, leaving behind mostly the dense metallic core we see today. Because this massive iron core has been slowly cooling down over billions of years, something amazing is happening. Mercury is actively shrinking. As the iron core cools and contracts, the rocky crust above it gets squeezed together. The crust buckles and snaps, creating massive towering cliffs hundreds of miles or hundreds of kilometers long and up to a mile, or 1.6 kilometers high. These features are known as Lobart scarps. In total, the entire planet has shrunk by as much as 4 miles, or 7 kilometers, across its diameter, leaving its surface covered in these vast planetary wrinkles. Despite its small size and agonizingly slow rotation, that iron core does something else remarkable. It generates a global magnetic field. Though it is only about 1% as strong as Earth's magnetic field, it creates a protective bubble around the planet that deflects incoming solar radiation. Mercury and Earth are the only two small inner rocky planets in our solar system that actively generate a global magnetic field today. Now, here is a final puzzle. Even though Mercury is millions of miles closer to Earth than distant worlds like Jupiter or Saturn, it is actually one of the hardest places in the entire solar system for spacecraft to reach. In fact, it requires more energy to reach Mercury than it does to travel all the way to Pluto. Why? Because of the Sun's titanic gravity. As a spacecraft travels inward toward the inner solar system, the Sun's gravitational pull pulls on the ship, accelerating it faster and faster. By the time a probe reaches Mercury's distance, it is moving way too fast to simply drop into orbit. It would fly right past or crash directly into the Sun. Because Mercury's own gravity is so small, only about 38% of Earth's gravity, space agencies have to spend years executing complex braking maneuvers. Probes like NASA's Messenger and the European-Japanese Bepi-Colombo mission have had to fly past Earth, Venus and Mercury multiple times over several years, traveling hundreds of millions of miles or over 1 billion kilometers, using the gravity of those planets like cosmic speed bumps to slow down enough to finally enter orbit. Despite being so close to us, Mercury remains one of the least explored planets. Only 2 spacecraft have ever orbited it. The first was NASA's Mariner 10, which flew by 3 times in the 1970s and mapped under half the surface. It wasn't until NASA's Messenger probe entered orbit in 2011 that we finally mapped 100% of Mercury's surface, revealing the ice-filled craters, magnetic secrets, and shrinking crust we know today. Mercury proves that you don't need giant gas clouds, complex ring systems, or dozens of moons to be one of the most exciting worlds in the universe. It is a tiny world of absolute extremes, where water ice lives inside cosmic ovens, where the entire planet is literally shrinking, and where time moves in ways that defy common sense. So the next time you look up at the night sky, remember the little grey speed demon silently racing around our sun.